Hello everyone, in this session I will share with you the inverse Laplace transform using the partial fraction expansion method. So let's look at the example. Write the following expression in partial fraction form, then find the inverse Laplace transform. The first question is inverse Laplace transform of 16 s squared divided by s minus 3 and s plus 1 squared. You can see that the root is s minus 3 and s plus 1. So we can, using the partial fraction, we separate into a plus b and plus c. Therefore, 16s squared is divided by the s plus minus 3 and s plus 1 squared. So this is from the question, equal to a divided by s minus 3 for the first one, and then plus b equal divided by s plus 1, and then plus c divided by s plus 1 square. Okay, so this is based on the root of the equation. So then this whole part we move to the right hand side, so we left 16s squared equal to a s plus 1 square. Okay, we can cancel out the s minus 3, so we left s plus 1 square, and then plus with b s minus 3 and s plus 1 only, because we can cancel out with this one s plus 1, and then plus c s minus 3, because we can cancel out the s minus 3 s plus 1 square, so we left s minus 3. Then from here we can assume the s is equal to 3 or s equal to minus 1. So now let's assume s equal to 3, and then we left 16, and then 3 square equal to a. Okay, if we assume s equal to 3, so this one s equal to 3 will equal to 0, this one also equal to 0, so we left the a. So a equal to so a and multiply with 3 plus 1 square. So 3 square we get 9, 9 times 16 we get 144, and this one 4 square you get 16 and 16a. So a is equal to 144 divided by 16. This is equivalent to 9. Next, we assume the s is equal to minus 1 into the equation, and then we have 16 minus 1 square equal to, okay, if you look at here, if s is equal to minus 1, so this one will equal to 0, this one also will equal to 0, so we just left the c. So c minus 1 minus 3. So this one we have 16 equal to minus 4c, and c equal to 16 divided by minus 4, and this will equal to minus 4. And next we assume the s is equal to 0, so we substitute the 0 into the equation, and then we have 16, 0, and a multiply with, okay, so we insert or we substitute the s equal to 0 into the equation, so we have the a, and then we left 1 power of 2. Okay, so 1 power of 2 plus b minus 3 1 plus c minus 3, so this is equivalent to 0, and then a minus 3b minus 3c. So 3b, I bring the 3b to the left, so I left and then a is equal to 9. From the first part we get a equal to 9, c equal to minus 4, so we can substitute in. So 9 minus 3, okay, minus 4, this is the c value, 3c. So this will equivalent to 9 plus 12. Okay, so b is equal to 9 plus 12 divided by 3. So this will equivalent to 7. Okay, so now we have the value of a, b, and c. Okay, so we can substitute in the equation. So this is the original 16s squared divided by s minus 3 and s plus 1 squared. Okay, so inverse Laplace transform. So we have the ABC, so we substitute in. The A is 9, and then plus with B is 7, and then C is minus 4. So we substitute in. Okay, so from here it can be easily convert from the inverse Laplace transform to we can convert from the S domain. Okay, so now inverse Laplace transform of 9 over s minus 3. Okay, from the table of Laplace transform we know that the exponent at is equivalent to 1 over s minus a. So this is from the Laplace transform table. Okay, so this means, okay, in this one, this is the 9. 9 is referred to the constant. Okay, we can take it out, and 1 minus s minus 3. So s minus 3, if you compare this one, is referred to the exponent at, right? So this is the a is equal to 3, so you have exponent 3t. So we left inverse Laplace transform of 1 over s, and then plus with 7 is a constant, so we can take it out, 7, and then again this one, s plus 1 is equal to exponent minus t, and then we have inverse Laplace transform of 1 over s, and then minus 4. Okay, s plus 1 again is what? Again is referred to the exponent minus t, and then inverse Laplace transform 1 over s squared. Okay, so now what we do have? Now s9 exponent 3t. For this part, okay, if you still remember the Laplace transform table, okay, this is the Laplace transform table. If the fs is a over s, ft is a. So just now is 1 over s, your ft is 1. So this part will be 1, and this part also 1. And for this one, you still remember? So this is referred to t power of n. You obtain n square s n factorial divided by sn plus 1. So just now your case is 1 over s squared. So means that this is 1 over s power of 2. So this is t power of 1. So it is t power of 1. So now this is plus with 7 exponent negative t minus 4 exponent negative t, and this one is equal to t. So that's how you get the ft. Second question is inverse Laplace transform of s divided by s squared minus 2s plus 2 and s squared plus 2s plus 2. In this question, the denominator is referred to the s squared and s. So we need to split it. Okay, we split it into as plus b. Okay, and s squared minus 2s plus 2. And then another one is, okay, cs plus d. And then this is the s squared plus 2s plus 2. Okay, we split into 2. Alright, so we multiply in the whole denominator. We bring up to the right hand side. So this will equivalent to s equal to as plus b. Okay, multiply with s squared plus 2s plus 2. For the s squared minus 2s plus 2, we can cancel out. And then plus with cs plus d. Multiply with s squared minus 2s plus 2. Because the s squared plus 2s plus 2, we can cancel out. So we can multiply in. We multiply in each of them. Then this one. Okay, so I multiply in, I get as power 3 plus 2as squared plus 2as. Then I start with the b, so bs squared plus 2bs plus 2b. Okay, next is cs. Okay, cs multiply with this one, then this one, and next one. So I have the cs power of 3 minus 2cs squared plus 2cs. Then I start with the d. So I have plus with ds squared minus 2ds plus 2d. So we need to collect all the s, okay? S power of 3, s power of 2, s power of 1, and s power of 0. So next, let's start with s power of 3. So we have x power of 3 here and this one. So we have a plus c, okay? And then s power of 3 plus with, then collect all the s power of 2. So we have this one, and this one, this one, and this one. So we have 2a plus b minus 2c plus d. So this is x power of 2, and then we collect the s power of 1 is this one, this one, this one, and this one. So it's plus 2a plus 2b plus 2c minus 2d. So this is for s power of 1, and then for s power of 0 you have 2b and 2d. Okay, next is by comparing the coefficient and solve the resulting system of the linear equation. So we start with the x power of 3 first, so we compare. So for the left hand side we only have the s power of 1. So for x power of 3 we have a plus c equal to 0. So this means the a is equal to minus c. So this is equation 1. Then for s power of 2 equal to 2a plus b minus 2c plus d equal to 0, whereas s power of 1 equal to 2a plus 2b plus 2c minus 2d equal to 1. And then whereas for the s power of 0 we have 2b plus 2d equal to 0. Okay, so okay, for s power of 0 is easy because we can take out this one will become equivalent to b equal to negative 2d. We bring the 2d to the right hand side, so we have negative 2d divided by 2, so we have negative d. Then I assume this one is equation number 2, and then this one is equation number 3, and this one is equation number 4. So now we substitute the equation number 1, okay, which is b equal to negative d, and equation 1 and 2. Okay, 1 is a equal to negative c, number 2 is b equal to negative d into the equation 3. Because equation 3 we have the a and the b. Okay, we substitute in. So we have the 2a plus 2b plus 2c minus 2d equal to 1. So 2 negative c, this is the value of a, and then value of b is negative d plus 2c minus 2d equal to 1. So negative 2c minus 2d plus 2c minus 2d equal to 1. So negative negative 4d. So this is negative 2, negative 2, so negative 4d equal to 1. This one can cancel out, okay, positive and negative you can cancel out. So d equal to negative 1 over 4, where the b is equal to negative d, and we get b equal to positive 1 over 4. So we get two values here, okay, b and d. So from equation 3 we have 2a plus 2b plus 2c minus 2d equal to 1. So we substitute the value of b is 1 over 4, and substitute the value of d is minus 1 over 4 into the equation 3. So we have 2a plus 2c and then plus with the value is 1 over 2, and this one also get positive 1 over 2 equal to 1. Okay, so 2a plus 2c equal to 1 minus 1. So we bring this one to the right hand side. So we have 2a plus 2c equal to 0. So this is equation number 5. Now from equation number 4, okay, we still have equation number 4, we haven't settled. So from equation 4, we have 2a plus b minus 2c plus d equal to 0. So 2a plus with b, we get 1 over 4 minus 2c, and then d is the value is 1 over 4, negative 1 over 4. And from here we get 2a minus 2c. So this one can cancel out. So a is equal to 2c divided by 2. This is equal to c. I assume this is equation number 6. So next is we substitute the equation number 6 into equation number 5. 6 is a equal to c. So we substitute in the equation number 5. So we have 2c plus 2c equal to 0. Okay. Equation number 5 is 2a. Now the a is equal to c. So 2c plus 2c equal to 0. So 4c equal to 0, c equal to 0, a also equal to 0. Now we have all the value a, b, and c, and d. So now let's go back to the question. So we substitute in all the a, b, c, d. So as, okay, I copy down again. As plus b equal to s squared minus 2s plus 2. Then plus with inverse, we have cs plus d, and then this is s squared minus plus 2s plus 2. A is 1 over 4, b is 0. Okay, so we left this one. And c is, okay, your c value is 0, and d is negative 1 over 4. So this is negative 1 over 4. Okay, now 1 over 4 is a constant. We can take it out. 1 over 4. 1 over 4. So here left. Okay, now is s squared minus 2s plus 2. So this one, how? We can factorize it. Can or not? If we factorize like s minus 1 square, what do we have? So we get s squared minus 2s plus 1 only. But in the question is plus 2. So we still not enough 1. So we need to add the extra 1. So therefore, if I factorize it, that is the s minus 1 square. We need to plus 1. So that is equivalent the value of here. Okay, for the second part also the same. I take out the constant, and then for this part also the same. Okay, so I can factorize it. That is the s plus 1 square. But what is it with enough or same value? So if we have the s plus 1 square, what do we get? That is a s square plus 2s plus 1, and in the question is plus 2. So we need to add the extra, that is the plus 1, so that the value of here is the same with here. Okay, so now 1 over 4 inverse Laplace transform of this one. So 1 over s minus 1 square plus 1. So what about this one? This one we can using the table of Laplace transform. Okay, so we can change to exponent t. So this part we can change to exponent t, and then we left 1 over s squared plus 1. Okay, and 1 minus 1 over 4. And then this part we change to exponent negative t, and then we left 1 over s squared plus 1. So 1 over 4 exponent t. For this part, okay, we can refer to the table. Okay, sine at equal to a over s squared plus a squared. Okay, so just now that one is s squared plus 1, so means that this is sine. So here we change to sine t minus 1 over 4 exponent t negative t sine t. So that's all for this question. The last question is inverse Laplace transform of s squared plus 9s plus 4 divided by s squared plus 5s plus 6. Okay, if you look at this question, s squared plus 9s, and this one is s squared plus 5s, means that it's a extra, it's more than that. So what should we do is you can use the by long divide. Okay, by long divide. Okay, so this is the s squared plus 9s plus 4 divided by s squared plus 5s plus 6. So we can have one only, so there is s squared plus 5s plus 6 with minus, and then 9 minus 5 we get 4. Okay, and then 4 minus 6 you get minus 2. Okay, so the answer here is 1 plus 4s minus 2 divided with s squared plus 5s plus 6. Okay, again we use the partial fraction. So partial fraction only use this part. Okay, so 4s minus 2 divided by s squared plus 5s plus 6. So I can have the a and b. So a divided by s plus 3. Okay, but before that I can factorize it. This one I can factorize. This means that is s and s, and then this one is 2 times 3. Okay, so this is a plus and plus, so I can get s squared plus 5s plus 6. So I use this as a root. Okay, so plus b equal to s plus 2. Now I have the 4s minus 2, and I bring this one to the right hand side, so I left equal to a s plus 2 plus b s plus 3. So since the root here is the s plus 2, so s equal to minus 2 and s equal to minus 3, so I can assume s equal to minus 2 first. So I substitute the s equal to minus 2 into the equation. So 4 minus 2 equal to b minus 2 plus 3. So I left minus 10 here equal to, okay, this is a minus 8 minus 2, so it's a minus 10. Here is a minus 3 plus minus 2 plus 1, so it's a positive b. So b equal to negative 10. Then we assume the s equal to minus 3. Now we have 4 minus 3 minus 2 equal to a minus 3 plus 2. So 4 times negative 3 minus 2 we get negative 14, and then negative 3 plus 2 we get negative a. So a is equal to 14. Now we can substitute in the equation. Okay, we use this one. Okay, we use this thing. So we have the inverse Laplace transform of 1. Okay, plus with inverse Laplace transform, the a value is 14, and then this is for s plus 3, and then b is minus 10, so you have minus inverse Laplace transform of 10 divided by s plus 2. So again, inverse Laplace transform of 1. we get delta t, okay, inverse Laplace of 1, we can get delta t, plus with 14 is a constant, we take it out, s plus 3 is, we change to the exponent, negative 3t, and then minus with 10, s plus 2 is we change to exponent, negative 2t. That's how we get the ft. So do you understand how to find the inverse Laplace transform using the partial fraction expansion? Okay, that's all for today. Thank you.